Good morning, ME4220 class. This is my second recording for today. This one is going to be some more pointers and suggestions on this latest homework assignment that you guys are working on. So to start out with here, let me put this down and let's put up the diagram. This is a good place to start. So on the chill water piping, this is the basic layout that I sent you. Kind of generally shows where things are situated in the building. That's the hot water, which I'm going to let you on your own on the hot water because I've given you bunches of suggestions on the chill water. Once you've done the chill water, the hot water should follow pretty darn close behind. This was where I had determined a scale. So for mine, 1 inch, when I printed this out on my paper and I actually measured it, that's where I measured the 6 3/8 inches. Inches was off of the sheet that I printed out, but at any rate, that made the scale. 1 inch was about 94, a little over 94.1 feet, something like that. And that's how I determined the pipe lengths. And this is where I just numbered the pipe sections so I could put them in Excel and work with them from there. But we talked about this previously. Okay, I wanted to go back and look at some of the details here. Some of this I may have talked about before and some of it I may not have. I kind of glossed over some of this in my first help video for you. Just wanted to kind of get you started. But now these are some of the details that we really need to include in a design. And so you see, and actually I think there's also in one of the other diagrams, there's a three-way valve arrangement on a chill water coil. So actually you could design around either one. I don't care. This is the one I picked. It just happened to be, I like this diagram. It's a nice detail. And this is the kind of thing you see on a set of plans. But at any rate, from our chill water or hot water in this case. So we would come in and the first thing we would have would be a line size butterfly valve for cutoff. And then we have a strainer. And this is a pipe union. I think I said, I ignored the unions. I don't know if there's probably not much of a drop just across a pipe union. These are gauges and such, so I don't think there's much. And then there's the drop of the coil, and you come back out on this side, and this would be another flange or union. This would be a potential reducer in size. You know, I didn't really give you enough information to spec a control valve, so I think it's fine to assume that the valve is the same size as the line, even though it might well be downsized a little bit for authority. So these are expander reducers. So this would be like expecting this pipe size to go down to the valve, and then this expands back up another union. Balancing valve, which you do need to include, and another butterfly valve. So of these components, you certainly need 2 butterfly valves, a balancing valve, a strainer, a control valve, and the coil. I would say that's probably pretty good to include in your design. Okay, I did not include, discuss this, and this is where the three-way valve installation is shown. I kind of like the other one a little better. It's got a little bit more detail. But this shows you the connections at the chiller. And so basically it just shows that we've got a butterfly valve in and out. I think this is probably a pressure sensor or something. I'm not sure. Well, that's pressure. Was it an M? Oh, well, that would be a motorized butterfly valve. You can just put 2 manual. That's fine. If you want to put a motorized valve, that's fine too. I don't care. And then around the pump, I got a couple details on pumps here. This one certainly says chill water on it. What we have here coming into the pump, we've got a butterfly valve. We've got a strainer. This is, I think, a sensor. This would be a union, that sort of thing. But so on the suction side, you've got these two. And you may want to put a suction diffuser on this. I'll talk a little bit more about that in a second when we get to the next diagram. The pump itself, another union. This would be a check valve. You definitely need a check valve here, and also a butterfly valve. So you need to pick up these valves, check valves, that sort of thing off of this diagram. Okay, and so here's another diagram of a typical pump installation. This is pretty good. This shows the separator, the bladder expansion tank. There's a list of all the different components here, which I think we've covered most of them in the class. So I'm not going to go over all of them. This is the suction diffuser, and you can select that on the Bell and Gossett website. It's very simple. What this thing does is if you have a long straight section of pipe going straight into this thing, you don't need a suction diffuser. But this basically establishes a really nice velocity profile for going into the pump. And if you have a situation like this where things are coming down and you got a bunch of elbows and your velocity profile is going to be all chopped up with a bunch of turbulence going into the pump, that can affect pump performance. And so you can simply put a suction diffuser on there, and basically it kind of eliminates a lot of that turbulence and gives a nice smooth velocity profile into the pump, and really helps the pump operate. And also this shows this triple duty valve on the discharge, which I wanted you to spec as well. It's really simple. Basically, you just determine your flow rate and go to that Bell and Gossett, I think it's the ESP selection program. It's just another tab, basically click on it and select one. So there's nothing hard about it at all. Okay. All right, so that's just where I was drawing the air handlers before. So let's look at my spreadsheet now. So I've added some stuff in, and I'm going to apologize. My spreadsheet, I think it may be correct. I've got so many things spread all over the place. It's not organized very well. Sometimes these things get the better of you. But let's look and see what I've added here. Let's get to say my first zone I did was north. And these were the piping sections that were involved in getting the supply and the return piping, say from the chiller and back to the chiller. And notice I've upped this. I had 20 feet, but when I did the calculation, the two butterfly valves, at least for me, added about a half foot each. So in order to get the drop of those open butterfly valves in there, I just upped the chiller head by 1 foot from 20 to 21. So that's how I'm getting that into my analysis. And I may not have done that on all of the zones. Now, see, I didn't do it on all of them, so I'm going to have to go back and change that. So details. Anyway, that'll get those two butterfly valves in. And then on these fittings, the E24 was my last piece of pipe. And so that was at the pump. I can show you where that was. Let's go back up here. There we go. So 24 is back here at the pump. So 23 is really on the suction side of the pump and 24 is on the discharge. But as far as pressure drop, it really doesn't matter here. I just, in my overall circuit, I have to get those in. So what I did is I came back, and after E24, that's the elbow in section 24, the way I drew it. So I just added all of these devices. So I added butterfly valve, strainer, suction diffuser, check valve, triple duty valve, butterfly in, butterfly out. I think I have one too many. I have one too many butterfly valves. So I'm going to have to go back and modify this. So I put 3 butterfly valves in because I put 2 in up here because these things are coming out, yeah, about 0.49 feet. And so these are the two around the pump, and this 1 foot is the two around the chiller, and I've got an extra one. So I've got some modification to do. I'm sorry. It's I tell you, as you go back and kind of piecemeal this thing, it's hard to get all this stuff in the right place. But anyway, then I added all of that to each zone. Okay, and so you can see this is core, you know, butterfly, all that stuff. And so I'll come back and take this first butterfly valve out of all of this. And I'll knock about a 1/2 foot off of this. So it's not critical. And then the other thing I did, in my actual sizing of my pump, this is my summary. And of course, this will change when I do my little corrections. But I put in a 10% safety factor, which I think that's probably conservative. I think you would probably see probably a 20% in terms of making sure that you have enough pump head and this is at 600 GPM for the chill water piping. But it's probably prudent to put at least a 10% safety factor just to make sure that pump is strong enough. Because, you know, when you get out in the field and this stuff actually gets installed, believe me, it doesn't look, when you go inspect them, they don't look quite like if you draw them up. And, you know, I mean, that's just the reality of it. And sometimes there's extra bends and elbows, and contractors have to do things to make stuff work. And you don't want that to invalidate your pump selection. So at any rate, I guess I will end this video right now, and I'll go about the business of fixing my solution to this. And it's about time that I moved on to the hot water system, but I kind of wanted to get this one worked out. And then what I'll do is I'll copy everything off of this sheet to another sheet, and I'll call this one chill water and the other one hot water. And then I'll go about the business of editing this one into the hot water system, which should be pretty similar, I'm hoping, so that maybe it won't take quite as long as this one has. So that's it for now. Hope you're doing well, and I'll get this out to you soon. Take care. Stay safe.